Alright, in this video we're going to be talking about how to write equations when given a graph. So before we were given different transformations and how to write the equation. Now we're going to be given a graph and we have to figure out, okay, what transformations happened? How would we put that into the equation to find it? And we're going to be going back and comparing this in the graph so that we can double check ourselves. So with this, one, you have to think about where is my parent function? Where would that usually be? So if you need to, go back in your calculator, regraph that, find those points, and graph that next to this. On top of it, it doesn't matter. So if we did that, our parent function would start at 0, 0, and would go 1, 1, negative 1, 1, 2, 4, negative 2, 4. So as I'm looking at the parent function and I'm comparing it, it looks like our new function was moved to the left 2. So if we're thinking back to what that transformation does, that would be on the inside. So we'd start off f of x equals inside, but it needs to be the opposite. So instead of putting minus 2, we're going to put plus 2. And because it is a quadratic, we would put squared. So again, just to be sure, go ahead and clear all this stuff out. Just to double check my work, if I put in x plus 2 squared, it should look like the function that was graphed, and it does. Okay. Now for number 2, I have an absolute value function. So we have to think about where would our parent absolute value function be. So remember that one starts at 0, 0 also, but this one is like your lines with a slope of 1 and negative 1. You go up 1 and you keep going up 1 to the right 1, up 1 to the right 1 for as many points as possible. I'm going to extend this a little farther than this graph actually goes, but that's okay. And then same way the other way, up 1, I'm sorry, rise over run. Up 1, left 1, up 1, left 1, keep going. I'm just going to fill up this graph. So as I'm comparing this, it looks like this vertex was moved to the left 2, just like number 1 was. And I could have circled that here and drawn that arrow as well. And it doesn't look like anything else happened to it. Mine is just bigger because I extended more points. If I extended the amount of points on the original, same thing would happen. So by the same logic from number 1, I could say this is f of x equals the absolute value of x plus 2 squared. That doesn't really look like a squared. And I'll graph that just so we are all sure. So alpha window will give us absolute value, x plus 2 graph, and it has been moved to the right or left 2. All right, moving on. We're not going to do every single one of these, but we are going to do some. All right, for number 3, again, my parent function, and this is absolute value, was this. I'm not going to graph as many points as I did before. But from what I can see, this definitely was flipped upside down because it's now facing the other direction. But my vertex is also now up here. So this was also moved up. So flipped upside down and moved up 1, 2, 3, 4, 5. So if I were to write that function, it'd be f of x equals, flipped upside down would be a vertical reflection, so that would be outside the absolute value of x plus 5. I'm going to put that in my calculator just to make sure that that's accurate. So I'm just going to change the way this, actually, I'll just clear it out. So negative alpha window for my absolute value, x, and then plus 5, and graph. And it is, in fact, upside down and moved up 5. Okay. Number 4, if this was my parent function, it looks like this was moved to the right 3 and up 1. So the right is going to be a horizontal, so that's inside. Up is going to be vertical, so that's outside. So that's going to be f of x equals, in parentheses, x minus 3, because we're doing the opposite, and then plus 1. I could also look at my vertex of this is 3, 1. So the 1 would be positive and the 3 would be negative in my equation. And I could go in my graph and plot those points, or put this in my calculator. X minus 3 squared plus 1. Oops, I didn't type that in correctly. Let's try that again. There we go. Now it has been moved to the right 3 and up 1. All right. We'll do 5, we'll do 6, and we'll do 7. We'll do 5, 6, 7, 8, and then we'll stop there. Okay, so for 5, this was, as you start doing this, before I finish that statement, you should be able to picture where the parent function is without graphing it every time. But if you still need to graph it every time, feel free to do that, because it does kind of help you visually see where it was. I think I did one too many. That was not straight at all. All right, so my vertex point has been moved to the left 2, down 1, and it's been reflected over the x-axis. So what did I say? Left 2, down 1. Wow, I did not spell that correctly. Ignore. Flipped upside down. So this should be, if I'm thinking about my transformations correctly, so f of x, it's flipped upside down. That's a vertical transformation, so that would be outside. Moving left would be inside, but it needs to be the opposite, so that would be x plus 2. Moving down 1 would be outside, and that'd be a minus 1. So let's put that in the calculator and see if that works. So that would be negative absolute value of x. We're moving left, so that would be plus 2 minus 1. It's flipped upside down. It's moved left 2. It's moved down 1. All right. Now number 6. If this was right side up, and now it's right side down, down side. Anyway, I don't know what I was trying to say just then, but now it's upside down. It was definitely flipped. It was definitely moved down. So that's 1, 2, 3, 4, 5. Now, If it was just flipped and it was just down, it would look something like this. But that's not how it looks. It's stretched out. So let's say it's stretched. Stretch was probably a bad word. It's going away from the y-axis. And if you think back to our transformations, you could also say it's going out towards your x-axis. There are different variations here, but we're just going to focus on the y-axis one. You'll learn more about the x-axis one in Algebra 2. So if this were compressed, because that would be the only way it shrinks away from the y-axis, we would need to find the value of that, the scale. So to do that, we would, because these are lines, this is really nice to do, we can count the slope. So if we start here and we end here, we'd be going down 1 to the right 3. So the scale would be 1/3, which means we'd be vertically compressing. So that means our function would be f of x equals negative, because it's flipped upside down, that'd be on the outside. The scale would also be on the outside because it's a vertically compressed, the absolute value of x, and we're moving down 5. So negative 1/3 x minus 5. Let's check that and see if we get the same thing. Oops, I forgot something. Negative 1/3 times the absolute value of x minus 5. Minus 5? There we go. Graph. And look at that. It matches. Absolute value is really easy to find the scale factor for because you can count the slope. Quadratics are a little bit tougher, but I'm going to show you what happens. Okay, so our parent function would look like this. So it's definitely been flipped upside down. It was definitely moved up by 2. Now, we can definitely see it's gotten longer or narrower. And to see by how much, we're going to look at our y values. So let's compare we are going to compare the y values, but let's think about it like this. Let's say it wasn't shifted up to, and it wasn't flipped upside down. So I'm going to erase my parent function. So if it wasn't shifted up to, this would be down here, this would be down here, this would be down here. Oh wait, but I'm also flipping it upside down. Sorry. Let's do it like this first, and then we'll flip it. Okay, so this would be down here and down here. Now I'm going to take those same things and flip it back up, right side up. So this would still be here, this would be here, this would be here, and 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, somewhere up here. So this would be if it was right side up. Now, we're going to compare this to our parent function. So I'm going to briefly just draw this really fast. So if the purple one, this dark purple one to the right is our parent function, and we're comparing our y values. So let's compare this one to this one. The purple one is at 1. This magenta pinkish one is at 2. Okay, so the only way we would get from 1 to 2 is if we multiplied, but we have to make sure that rule applies for everything. So now this one, the y value is at 4, and this y value is at 8. If we multiply 2 by 4, we would get 8. So to help us find that scale factor, we can do that, do what we just did, and now we can say that this was multiplied by 2. So our function would be f of x equals, flipped upside down would be outside, so it'd be a negative. The scale factor would be outside, and then it's moving up 2, so everything here is going to be outside. You can put this in parentheses to show that the plus 2 is still on the outside, but you don't need to do that. So if I put this in, this should match. So y equals negative 2x squared. Oh, it was also moved up. So it was moved up 2, it was vertically stretched by 2, and it was flipped upside down. So for this last one, let's say we went ahead and did that same thing. One, you can tell it's wider. You could also think about it like this. So you know the originals are at 1 and 4, but now they're changed. So let's figure out what that new scale is. So I'm going to fix this so it would look like the original. Let's figure out what happened to it first. It was flipped upside down. This has been moved to the left 3 and up 4. And it was stretched by, compressed by some scale. So in order to find that scale, if this was flipped right side up, it would be, I'm just going to flip all of these points. Actually, what did I do for the first one? I moved it back down. So here we'd have to move it back to the vertex, or back to the origin, and rearrange it. So we'll do a couple things. We'll just flip it right side up first. So instead of down 2, it'd be up 2, and it would keep going. I don't have space to do all of that. And then if I put it back here, this would be up 2 to the right 2, up 2 to the left 2, and then I'm going to kind of look at these points backwards. So here, this is going down 1, 2, 3, 4, 5, 6, 7, 8 points, and to the left or right, 1, 2, 3, 4. So I would do that same thing the other way. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So I know it's kind of hard to see because I have a bunch of stuff going on here. Okay, so now if I want to look, compare my y values to the original. It was at 1, now it's at 2. Okay, so did I multiply it by 2? But this one is now at 8. I'm sorry, the y value is at 2, but it's gotten wider. So that means we have to divide it by 2.
So if we're dividing it by 2, then our scale would be 1 over 2, which means our function, if we're putting everything together, would be f of x equals, so it's flipped upside down, so that'd be a negative on the outside. We'd have 1/2 on the outside. It's moving left 3, so this would be inside plus 3. And then up 4 on the outside. So the last thing we're going to do is put this in the calculator and make sure that what we have is correct. So in my calculator, I'm going to go into y equals, and I had already put this in, but negative 1/2 x plus 3 squared plus 4, and we're going to graph it. And just to make sure, I'm going to go to my table because it looks like it's the same, but I just want to double check. And we're going to look at some of these points. So the points that were originally on there, I'm just going to write these down really fast. We had 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 7, or negative 7, negative 4. 1, 2, 3, 4, 5. Negative 5, 2. 1, 2, 3, 1, 2, 3, 4. Negative 3, positive 4. Negative 1, positive 2, and then 1, negative 4. So I'm going to look for those points. So when x is negative 7, we get negative 4. When x is negative 5, we get 2. When x is negative 3, we get 4. When x is negative 1, we get 2. And when x is 1, we get negative 4. So even though it looks like it, but maybe it doesn't a little bit, it is actually the exact same one. So now you'll have time to go and practice. Let me know if you have any questions.